George, thanks for joining me today. George is with Sierra Radio Systems and also with Pactena. And today we're talking about his station controller from Sierra Radio. Thanks for joining me, George.
Yeah, thanks, Mike. Appreciate being here.
So, George, let's talk about why we would want to do it remote. I listened to one of your podcasts recently where your guys were talking about reasons why we remote. So let's talk a little bit about that.
Sure. We've seen a growing interest in remote operating for a couple of different reasons. I think from a personal perspective, a lot of people live in apartments or they live in HOA antenna restricted places, or maybe in a retirement home where you can't put up an antenna. And so the idea that having a station somewhere where you can operate that's not at your primary residence is becoming more and more desirable. And also, a lot of people would like to put up a station in a low noise area that's far away from the city and gives you better performance or maybe a higher elevation. So there's a lot of drivers, I think, on the personal side of why people want to operate. Another thing we see also is a lot of people would like to operate the radio while they're traveling. Maybe they're on vacation or they're on a business trip, you're stuck in the hotel, and you wish you could operate the contest while you're, in a hotel 1,000 miles from home. So there's just a whole lot of reasons why it would be desirable to be able to operate these days.
Oh, awesome. Okay. So let's dig into your station controller, because the station controller is more than just control a radio. It's a lot more than that. So let's dive into that.
Yeah, in fact, it's not control the radio, it's control everything else. So what we observed is that in the last 5 or so years, there's more and more radio manufacturers realizing that remote operating is a big deal. And the company that really did the most to drive that, in my opinion, is Flex. So Flex Radio from the get-go made their radios easy to operate remotely. And a lot of other radios had serial ports, but the ability to remotely control them was still an external piece of hardware. But now we're seeing a lot of the brands, like you mentioned, ICOM, Elecraft, and others building remote control of the radio into the radio itself. And so when we looked at this, really this opportunity to make it easier to set up a remote station, our observation is that the remote control of the radio is really a problem that's being solved by the radio manufacturer themselves. And so that's not really something we wanted to focus on. So we looked at it and thought, well, what's missing? And what's really missing is that everything else that sits around the radio. Because when you set up a remote station, it's kind of a big science project. You've got to be able to turn things on and off. You've got to be able to switch antennas. You got to be able to monitor all kinds of vital signs of the station. Temperatures, wattages, voltages, switch closures, and you're really on your own to go figure out how to make that happen. And a lot of people have done that, and they've cobbled together their own solution. But there really wasn't a commercial off-the-shelf product that you can just go buy and set up and do that station control and monitoring in any convenient way. And so that's really where we focused our station controller project.
Okay. So you talked some about monitoring already, but what kind of things do you want to control in your shack?
Well, first of all, one very fundamental thing that's important is when you have a remote station, you have to have positive control on the station. So you have to have some way to physically disable it. Let's say the transmitter gets keyed and stays on the air and you lose control over the radio. That's not acceptable. You have to have a way to turn the system on and off. So there's minimally, from a safety point of view, the need to be able to turn the transmitter off. But you may want to leave your station completely shut off until you want to use it. Maybe you're on battery or solar. So you want to be able to turn the AC power supply on and off. Maybe you want to gate DC power to various devices. You want to be able to switch antennas, because maybe for different bands, or you want to change antennas around, or a backup antenna. You can imagine there's a lot of things you may want to turn on and off. Maybe a heater, maybe you have a power amplifier you want to switch in and out of the circuit. So there's a lot of things you may want to turn on and off or switch in and out.
Okay, so let's dive deeper into how this whole thing works. I know that you control it with the Raspberry Pi, but let's dive into that deeper.
So when we architected the system, we really wanted to focus on building the control modules, which is the hardware that actually does the sensor measurements, RF power, DC voltage, et cetera, and control relays and so forth. And then we thought, well, how are you going to actually interact with all of that stuff? And one of the downsides to building your own system is that you can go buy a bunch of random things from vendors on Amazon or eBay or whatever and cobble it together. But if you have a web-enabled anything like a web-enabled outlet strip, it is controlled by itself. If you also have a remotely controlled coax relay, that's a different thing with a different control user interface. So as you build out your station, if you have 5, 6, 7 things to control, they all have a different interface, maybe a different IP address, et cetera. So the idea was we want a central place where you can control and monitor everything from a single dashboard. And at the same time, we saw a huge interest in using Node-RED in the amateur radio world, and that really started a few years back. And I would say today that's by far the most popular way to control a station. So Node-RED is a controller programming environment that presents a web page, a graphical user interface to the user, and it uses what's called flow coding. It's not like lines of code. You use objects, you pull them out of a palette, you stitch them together. And so for a non-programmer, it's fairly easy to actually create or modify your own control panel. And it's all open source. And there's a Node-RED user group right now on groups.io that it's got like over a couple thousand members. So there's a lot of smart people that are doing this already. So you don't have to invent the wheel yourself. So,
Right.
so we said, well, rather than to create our own proprietary thing, let's just use Node-RED as the control surface, the dashboard. And so we'll build all of our modules to work with Node-RED, and we'll supply pre-existing flows for our modules in Node-RED. So all you need to do is install them, and then you're up and running. You don't have to touch any programming at all. And by the way, Node-RED, as we supply it, you can get a Raspberry Pi from us with everything already installed on it. So you literally plug and play. But Node-RED is totally portable. You can have your own computer. It could be Windows, it could be Linux, it could be whatever. You can have your own computer, install Node-RED, and have it talk to our modules without using our Raspberry Pi computer. We supply it because it's convenient for you, but you can run Node-RED on almost anything.
Okay. So how difficult is this all to set up? I know that you have
We,
multiple boards that you have,
yeah,
and so how do you get it all put together?
we spent a lot of time figuring out how to do it right, and we've had several years of experience in industrial automation and working with customers that would get our hardware and software for in other industries and set it all up. And we made a lot of mistakes and learned from those mistakes. And so I think with the station controller, we hit it just right. So the way the system physically is set up, let's say you have a basic station controller, which is one module is the Raspberry Pi computer, another module, let's say, is a general purpose IO module, maybe a third module is a relay antenna relay switch module. All of the modules have RJ45 connectors, so the Ethernet kind of connector on them. And the Raspberry Pi module has 3 of them, so it's a hub. So you take a piece of Cat5 cable, you plug it into the Raspberry Pi board, and you plug it into the module. So there's 2 of those. And then you can apply power to any of the modules. Let's say you plug the power into the Raspberry Pi module, and you plug your actual Ethernet network into the Raspberry Pi. As soon as you do that, the thing boots up, and a minute later it's online. And when it boots up on the LCD panel on the control module, by the way, the modules look like this. When the control module boots on the LCD panel, it'll display the IP address of the Raspberry Pi. So literally, you plug in a couple of Cat5 cables, you plug in the power. A minute later, it gives you the IP address. You point your web browser to that IP address, and you're up and running. I mean, that's it. There's nothing else you have to do except to wire things up. Like, you're going to plug in your antennas and your radios into the coax switch, or, wire your DC control to your power supply or whatever it is you're hooking up. But the system itself, you're up and running in 2 minutes.
That's awesome. Okay. So we've talked a lot about HF, but how about VHF, UHF, whatever?
Yeah, there's really several applications for this. So when we talk about a station controller, most of the time we talk about it in the context of an HF remote. And in radio applications, everything that we're making is equally applicable to a repeater station or a VHF remote station. So for example, as a repeater owner for many, many years, I always wanted to be able to monitor critical points in the repeater system. So I want to monitor is AC on at the site? I mean, AC power as well as air conditioning, by the way. Is AC on or not? What's the temperature in the cabinet? What's the temperature in the room? What's the voltage coming out of the power supply? What's the RF power coming out of the transmitter? What's the SWR on the feed line to the antenna of the repeater? So here's the scenario with the repeater. One day you wake up and you go to, key up your repeater and there's nothing there. Like, well, what's wrong? Did the power supply fuse blow? Did the PA burn out? Did the antenna fall off the tower? I mean, it could be 10 things, right? So before you spend a day driving to the repeater site, and hopefully you have a truck full of replacement parts, if you could look at the dashboard and you can see what's going on, I could see I've got 12 volts DC coming out of the power supply. That's good. I can see that there's power at the transmitter, and I can see the transmitter is being keyed, but I see very high SWR on the feed line. Oh, okay. So the PA is probably okay, but maybe I got water in the feed line. So you can use the system to instrument a repeater site and start to understand what's going wrong. The other nice thing about this is you can even set up trigger conditions. So you can say, for example, I don't want to look at the dashboard ever. I just want to know when something goes awry. So maybe I'm going to monitor the SWR on the feed line, and I have a 100-watt transmitter. If I ever see the reflected power go over 5 watts, send me a text message. All that is very doable in Node-RED, and we provide all the hardware modules to do all that kind of control. So for repeaters, it's equally applicable. Funny thing is once you kind of get into using these things, you think of other applications. I've got an electric fence, which turns out to be a pretty good RF generator on 20 meters. And so I took one of the control modules and I put it down at the electric fence transformer. And so from the shack, I can I can turn the fence on and off, and without having to leave the house. So as you get into it, you think of more and more automation.
Next door neighbor with a pool pump, I'd like to have it be able to turn off.
Hey,
So, but at any rate, okay. So let's talk about what you have coming in the future, because I know you have more stuff that you've got in the
yeah,
pipeline.
yeah. As a matter of fact, there's two new things in the pipeline. One thing we're doing right now is this new control module, which looks similar to the other ones, but the difference is that the outputs, there's a bunch of small signal relays here and some jumpers. This is a kind of a universal coax relay switch controller. So right now we make an HF and 6-meter 4-port coax switch. So 1 in and 4 out. This could be 1 antenna to 4 radios or 1 radio to 4 antennas. And we also make a 2-port VHF UHF version. But the most common request that we got is to have a kilowatt antenna switch. And so we started designing the kilowatt antenna switch, and then it occurred to me that DX Engineering already makes them. And so making yet another one didn't seem to make sense. And so we started talking about how we could automate some of the DX Engineering products. And it turns out that there's several coax relays and other antenna switching systems that DX Engineering makes that are all controlled by a knob or push buttons. And we can emulate that with this new controller module. So what this means is, like, the one of the really nice ones is a 2x8 coax switch. And in order to control that, you would run 2 9-conductor control cables from the switch to the shack. Now, if your shack is 300 feet away from the tower, that's a lot of cable. So what we can do is we can replace all that cable by putting, depending on the switch, 1 or 2 of these at the coax switch itself, hooking up, 1 foot of cable to the relay. And then you could either run a single piece of Cat5 cable back to the shack that provides power and data to the module, or you can use some data radios that we sell, like this guy here, which is a 915 megahertz data radio, which allows you to put 1 in the shack and 1 at the tower. And now all of that control goes over the wireless data link. And obviously that saves you even more cable. So there's a lot of options there. And this guy is a bit universal because different antenna control modules have different combinations of outputs, and some are 12 volts to switch, and some are ground to switch, and some are 1 of 8, and some are some mask of bits, on and off combo. And so we're going to pre-program this thing with 10 different DX Engineering products. So you just set the dip switch for the personality, and when the Node-RED code says set your antenna to position 5, whatever that is, you'll get the proper output to the controller. So you can use this in many different applications. So that's I'm really excited about that one because I could use that myself.
I've can use that as well. So okay, very good. All right. So uh, is there anything else that we should cover before we
Yeah,
before
I
that?
think just the one last thing is part of the architecture for the system. Again, something we learned over many years is to abstract the control of the modules away from the medium. What I mean by that is that we define our own control protocol, which, by the way, we've published. So anybody that wants to, build your own controller or write your own software to control our modules, we publish the specs. So it's defined. It's like the cat commands for your radio. It's the equivalent of our system. But the important thing is the way you transmit data between these modules. Um, these RJ45 connectors that are on our control modules aren't Ethernet. So there's 8 pins, right? And of the 8 pins, 4 of the pins are used for power, 12-volt power, like PoE, but 12 volts. And 2 of the pins are used for data. And the data that we use, the physical interface, is called RS-485. And RS-485 has been used in industrial automation for decades. And it's really good because you can string wire thousands of feet, and like a piece of Cat5 cable or a twisted pair, and it's very easy to install, and you can multi-drop multiple devices off of that twisted pair. So you can provide power and data to a module. It could be across the shack, across the house, across the field, or like I said before, if you don't want to use the cable, you want to go with a data radio to transmit the data between it. The system handles that perfectly fine. And in fact, I've got one customer who went from our module into Ethernet and then across his regular LAN and comes out Ethernet. So our communications protocol can sit on any kind of medium. So we provide a turnkey thing with a cable, or you can provide your own kind of backhaul. Um, I'm actually pretty excited about the architecture. It's worked out really well, and it lets us really extend this very easily. The last thing, Mike, I want to mention is one other thing that we're starting to work on is a series of small control modules we call mini modules, and this is the first example of a mini module. So it does not have a controller in it. It is simply, in this case, an antenna switch. It's a 2-port antenna switch with latching relays. So sometimes you want a real, fully functional thing, and sometimes you want to just add a power switch. We have a high current 12-volt DC relay mini module, the 2-port BNC mini module. We've got some others coming down the pipe. So we're really building a kind of a whole platform of hardware compatible options, so you can mix and match and build out your station. Oh, sorry, one last thing. Speaking of mix and match, um, there's kind of no limit to the number of modules you can have. Every one of the modules gets its own unique address. And so if you decide, well, I want 4 modules of the same kind in the network, they just get a different address. And in Node-RED, it's super easy to extend the number of modules. You just copy the flow and you change one line in it to change the address, and you're up and running. So so it's very easy to extend the size of the system. So modularity is really a key thing.
Awesome. Okay. I do want to also mention that again, support is out there. You have a groups.io, your Sierra Radio Systems website. And if you want to know more about this, go back and do what I did. Listen to Ham Radio Workbench 226, and I'll put a link in the description where George talks an awful lot about how he went through to design all this. So, George, thanks for joining me today.
Thanks, Mike. Appreciate it.